Friends, welcome to the class. Today we'll discuss about probability. Friends, before we get into the chapter, first of all, let us know what is probability. We'll discuss the definition of the probability and definitions and the other terms that is related to the probability, and afterwards we'll see some practical questions. So let's start. Probability. Probability is the study of chances or likelihood of any event out of the total outcomes. Experiment. An operation which produces some well-defined outcome is called an experiment. For example, tossing of a coin, throwing a die, etc. The experiment is of two types: random experiment and deterministic experiment. What is a random experiment? If an experiment, when repeated under identical condition, do not produce the same outcome every time, but the outcome produced in each trial is one of the several possible outcomes, then that experiment is called random probabilistic experiment. For example, tossing of a fair coin is a random experiment because if we toss a coin, either head or tail will come up. But if we toss a coin again and again, then each time the outcome will not be the same. That means if we keep on tossing the same coin, then one times we may get head and afterwards we may get tail, or it may happen that continuously 3 or 4 times we may get head and afterwards we'll get tail in one time. Deterministic experiment. An experiment which, when repeated under identical conditions, produce the same result or outcome is known as deterministic experiment. For example, tossing of an unfair coin. Unfair coin means having either tail or head on both sides. So if we toss such kind of coin, then we will get the same result each and every time. The tossing of an unfair coin is a deterministic experiment as it gives the same result every time. Trial. A trial is an action which results one or several outcomes. For example, if a coin is tossed 10 times, then each toss is called a trial. Event. An event for an experiment is the collection of some correction of the experiment. It is denoted by E. That means what is event? Some of the collections of the experiment is called an event. For example, getting an even number in a single throw of die is an event. The event would consist of 3 numbers, 2 or 4 or 6. Elementary event. An event having only one outcome of random experiment is called an elementary event. For example, in tossing of a coin, possible outcomes are head or tail. Getting H or T. Let's head is denoted by H and tail is denoted by capital T. Getting H or T are known as elementary events. Occurrence of an event. An event associated to a random experiment is said to occur or happen in a trial if the outcome of the trial is one of the outcomes that favors the event. For example, if a die is rolled out and the outcome of the trial is 3, then we say the event getting an odd number has happened or occurred. Suppose we got, while throwing a die, we got the number 6. Then we can say the event of getting an even number has happened, like this. Probability of an event. If E is an event, then the probability of an event is given by PE equals to number of trials in which event has happened by total number of trials. Compound event. A collection of 2 or more elementary events associated with an experiment is called compound event. For example, in the random experiment of tossing of coins simultaneously, if we define the event of getting exactly one head, then it is a collection of elementary event. Then it's HT or TH. So such event is called compound events. Equally likely outcomes. The outcomes of a random experiment are said to be equally likely when each outcome is as likely to occur as the other. For example, when a die is thrown, all the 6 outcomes, that means 1, 2, 3, 4, 5 and 6 are equally likely to appear. So you can say the outcomes 1, 2, 3, 4, 5 and 6 are equally likely outcomes. Favorable outcomes. The outcomes which ensure the occurrence of an event is called favorable outcomes to the event. For example, the favorable outcome to the event of getting an even number when a die is thrown are 2, 4 and 6. Complement of an event or negation of an event. Let E be the event associated with a random experiment. Then we defined complement of an event or negation of an event which occurs only if and only if E does not occur, and it is denoted by E bar. For example, let E be the event of getting an even number in a single throw of die. Then its complement can be defined as the event of getting an odd number. That means if E consists of 2, 4 and 6, E bar consists of 1, 3 and 5. That is, whenever we are getting the odd number when we are rolling a die, then it is quite sure we are not going to get the even number, and vice versa. So that means if E takes place, E bar cannot take place. This is what the negation or complement of an event imply. So E and E bar are complementary events. The relation between complementary events are given by PE plus PE bar equals to 1. Impossible event. An event which is impossible to occur is called an impossible event. For example, in throwing of a die, there are 6 possible outcomes: 1, 2, 3, 4, 5 and 6. Let we are interested in getting a number 7 on throwing a die, but in a die there is no face marked with 7. So getting 7 in throwing of a die is an impossible event. Sure event or certain event. An event which is sure to occur is called a sure event. For example, probability of getting a number less than 7 in throwing a die. In this case, all the outcomes 1, 2, 3, 4, 5 and 6 all are less than 7. So this is sure event. Let's see some important points. The first one, probability of an event can never be negative. The probability of happening an event always lie between 0 and 1. If we express it in terms of percentage, the probability lies between 0% and 100%. The sum of the probabilities of complementary event of an experiment is 1. That means, as we discussed in the previous slide, PE plus PE bar equals to 1. The probability of an impossible event is always 0. Just like getting 7 in a throw of die, it is always 0. The probability of a sure event is always 1. Let's see some examples so that we can get how to derive probability or how to get the probability of an event. Now, there are various kinds of problem. Type 1 problem based on tossing of a coin. A coin has two sets: head, let it is denoted by capital H, and tail denoted by capital T. So in case of tossing of a one coin, the probable outcomes are H and T. That means total possible outcome is 2. In case of two coins, that means if two coins are tossed simultaneously, the possible outcomes are HH, that means head head, HT, TH and TT. That means in this case the total possible outcomes are 2 to the power 2, or it is 4. In case of three coins, if three coins are tossed simultaneously, the outcomes are HHH or HHT or HTH or THH or THT or TTH or HTT or TTT. That means in this case, the total number of possible outcomes are 2 to the power 3, or it is 8. Let's see an example. Two coins are tossed simultaneously. Find the probability of getting exactly the first bit, exactly 2 heads, and the second bit, at least 1 head. When two coins are tossed simultaneously, the possible outcomes are HH, HT, TH, TT. That means it is total number of outcomes is 4. So the total number of outcomes is 4. Now we know for an event E, the probability of the event is PE equals to number of outcomes favorable to E by total number of outcomes. So here total number of outcomes we got, that is 4. The first bit exactly 2 heads. Let E1 be the event of getting exactly 2 heads. The outcome favorable to E1 is HH. That means only in one case we are getting 2 heads. So the PE1, that is probability of getting 1 head, is 1 by 4 is the answer. Let E2, second bit, let E2 be the event of getting at least 1 head. So the outcomes are at least 1 head means it may be 1 head or more than 1. So here outcomes are HT, TH and HH. That means total number of outcomes is 3. So probability of getting at least 1 head or PE2 is 3 by 4 is the answer. Next, type 2 problem based on throwing a die. Before we get into it, let us know the features of the die. A die has 6 faces marked 1, 2, 3, 4, 5 and 6. So in case of one die, the possible outcome are 1, 2, 3, 4 and 3, 4, 5 and 6. So total number of outcome is 6. If 2 die is thrown at a time, then the total number of outcome will be 6 square equals to 36. Let's see an example. A die is rolled once. Find the probability of getting first bit a number greater than 4, second bit an odd number. When a die is rolled, the possible outcomes are 1, 2, 3, 4, 5 and 6. That means total 6 outcomes. Now the first bit says the number greater than 4, means the number 5 or 6. If we are getting 5 or 6, then only we can say the number obtained is greater than 4. So in this case, the number of outcomes favorable to the event is 2. So the probability of the number getting 4 is 2 by 6, which is equals to 1 by 3 is the answer. Second bit, odd numbers. In case of rolling of a die, there are only 3 cases we can get odd numbers. That is, if we get 1 or 3 or 5. So the number of possible outcome favorable to the event is 3. So the probability of getting an odd number is 3 by 6, which is equals to 1 by 2. Two die are thrown simultaneously. Find the probability of getting first bit multiple of 2 in one die, multiple of 3 in other die. Second bit, sum of the outcome is 10. Third bit, sum of the outcome is less than 5. When two dice are thrown simultaneously, the possible outcomes are like this. That means in this case, the total number of outcomes will be 6 squared, which is nothing but 36. Now, the first bit says multiple of 2 in one die and multiple of 3 in other die. So what is multiple of 2? Multiple of 2 are 2, 4, 6 and multiple of 3 are 3 and 6. So multiple of 2 in one die and multiple of 3 in another die means the outcome includes 2, 3 or 2, 6 or 3, 2 or 3, 4 or 3, 6 or 4, 3 or 4, 6 or 6, 2 or 6, 3 or 6, 4 or 6, 6. So the total number of favorable outcomes, favorable to the event, given event is 11. But what is the total number of outcome is 36. So The probability of the event is 11 by 36 is the answer. The second bit says sum of the outcome is 10. The sum of the outcome is 10. That means when the outcome includes 4, 6, 6, 4 or 5, 5. That is only in 3 cases we can get the total sum to be 10. So here the outcome favorable to the event is 3. So the probability of the given event is 3 by 36, which is 1 by 12 is the answer. The third bit, sum of the outcome less than 5. Sum of the outcome less than 5 means the outcomes may be 1, 2, 3, 4. So in this case, the outcomes will be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 3, 1. Because in all these cases, the sum of both the dice is less than 5. That means total number of outcomes favorable to the given event is 5. So the probability of the given event is 5 by 36 is the answer. Type 3. Problem based on playing cards. Let's see what is the feature of a card so that it will be easier for us to deal with the problem in finding probability of playing of a card. A deck of playing card consists of 52 cards, out of which 26 are black cards and other 26 are red cards, while the black cards consist of 13 cards of spades and 13 cards of club, and the red cards consist of 13 cards of diamond and 13 cards of heart. Thus, 52 playing cards are divided into 4 parts called suit of 13 cards each, namely heart, diamond, spades, and club. Also, 13 cards in each suit are ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 3, and 2. Face cards, king, queen, and jack are called face cards. So the total number of face cards are 12. That means there are 3 face cards in each suit, as there are 4 suit in a deck of 52 cards. So total number of face cards in a pack of 52 cards is 12. Let's see an example. The king, queen, and jack are removed from a deck of 52 playing cards, and then remaining cards are reshuffled. One card is selected from the remaining cards. Find the probability of getting first bit a spade, second bit a face card, third bit a card with an odd number. Here, king, queen, and jack of a spade has been removed from a pack of 52 cards or from a deck of 52 cards. That means the remaining number of cards which are reshuffled again is 52 minus 3, which is equals to 49. So you can say the total number of outcomes equals to 49. Now the first bit is spade. We know in a deck of 52 playing cards, there are 13 cards of spades. After removing 3 cards from the spades, the remaining number of cards in the spade is 13 minus 3, which is equals to 10. So here number of events favorable to the number of outcomes favorable to the event is 10. Let E1 is the event of getting a spade. So number of outcomes favorable to the event is 10. So probability of getting a spade or PE1 equals to 10 by 49. Second bit, a face card. We know in a deck of 52 playing cards there are 12 face cards. After removing 3 face cards from the spade, the remaining number of face cards in the deck is 12 minus 3, which is 9, because already we went through that in a deck of 52 playing cards, total number of face cards are 12, but out of 12 face cards, 3 face cards has already been removed. So here the remaining number of face cards is 9, or we can say the outcome favorable to the event is 9. Let E2 be the event of getting a face card. So the number of outcomes favorable to the event is 9. So the probability of getting a face card or probability of PE2 is 9 by 49. A card with an odd number. We know that a deck of 52 cards are divided into 4 suits containing 13 cards. and in each suit there are 4 number of cards with odd numbers. That means the cards containing 3, 5, 7, 9. Let E3 is the event of getting a face card. Is the event of getting a card with odd number. So the number of outcomes brought to the event is 4 into 4, which is equals to 16. Therefore, the probability of getting a card with odd number, or PE3, is 16 by 49. Is the answer. Friends, here we saw a few questions and only 3 types of problem on probability. In the next class, we'll discuss some more types of problem. So this was for today's class. We'll meet once again in the next class. Thank you.